so this is going on page 22 when we are finished. This is relation and function review continued. So this is a continuation of yesterday. I could have crammed it all in one day, but I didn't want to because there's just a lot to do on the first couple of days of school because you never know what the schedules are going to be like. Even though the processes that we do on here, definitely a review. I understand that maybe you've never heard that they are called explicit and implicit equations. That's okay. I'm not going to give you a vocabulary quiz. I want you to know what the words are, what they mean, so that when they're used in sentences, you at least know what they're talking about. Okay? I mean, that's the important part of that. So we have explicit and implicit equations. Explicit equations are solved for a specific variable. Solved for a specific variable. So for example, y equals 3x squared plus 7, that's solved for y, and x equals y cubed minus 5. Okay, so don't always have to solve for y, it could be p, q, x, whatever. But if it's solved for a variable, that is called an explicit equation. Then we also have implicit equations, and those are not solved for a specific variable. So we could have like x squared plus y squared equals 6. Can anybody tell me what that would graph? Learned it in geometry. Graph's a circle. Okay, so graph's a circle, geometry. Or we could have like 2y squared minus x equals 7. Either way, they're obviously not solved for a variable. They could be, an infinite amount of different things. So one of the reasons that it's important that you know these words is that it says here, write each equation explicitly in terms of y. So explicitly in terms of y, it's telling you it's an explicit equation and telling you what to solve for. Okay. So basically, we're going to have to take these, we're going to solve for y. Then it says, then indicate whether the equation is a function. So yesterday we looked at tables, we looked at mappings, we looked at what else do we do? Graphs and just ordered pairs and decide whether or not they're functions. Today we're going to look at some equations. All right, so on number 1, we're going to solve for y. Should be a pretty simple process here. So I'm going to subtract x from both sides. I get negative 4y equals negative x plus 20. I could have done 20 plus x, but that's not how it was drilled into my brain when I learned it, so I always put the variables first. Then I need to get y by itself, so I'm going to divide each term by a negative 4. So these cancel out, and I get that y equals, so negative divided by a negative is a positive. I could leave it as x over 4, but I don't want to. What's a different way to write that? 1/4 x. Very good. 1/4 x minus 5. Okay. So that is solved explicitly for y. Then I have to determine whether or not it is a function. There's a few different ways to do it. Well, one way is you should know when you graph that what kind of thing it graphs. What's it going to graph? A line, okay? So are all lines functions? Think about that for a second. Is a vertical line a function? No. So all lines aren't functions, but as long as it's not a vertical line, it is. Is this a vertical line? No. So that's all we need to know. That means, yes, it's a function. So if you recognize what it graphs, that can be very helpful to you. You should know your parent functions of quite a few things. You know what they, just look at it and you should think what it should look like with some transformations. All right, so let's look at number 3. To get y by itself, we're going to add x to both sides. So I'm going to have y plus 1 squared equals x plus 3. Can I subtract 1 from both sides at this point? No, I cannot. I have to take care of that square. What's the opposite of squaring something? Square root. Okay, so I'm going to take the square root of both sides. When I do that, that's going to leave me with y plus 1 equals the square root of x plus 3. What am I missing? What one? This one? Oh, no. Yeah, I know I'm not finished. Thank you. I'm not finished. But at this step, what am I missing? Because I'm missing something huge that would make this totally wrong if I don't put it. Yes. Plus or minus. And that is going to be the downfall of some of you. Plus or minus. There are two answers there. Anytime you introduce a square root, you have to put the plus or minus. So just to kind of make this make sense with something smaller here, if I take the square root of both sides here, this is going to give me x equals, okay, so I know the square root of 25 is 5, but there are two answers, right? Because 5 squared is 25, but negative 5 is also 25. So that's why I have to put the plus or minus. And if you don't, you're going to eventually end up in math jail. Y'all see my math jail over here with all my little criminals? Where is it? Right here. I introduced a square root and did not use plus or minus. So if you put a square root wasn't there, you did a square root to solve the problem, then you have to put a plus or minus. Make sense? There are times where we don't consider one or the other. Like let's say, like in geometry, you may not have, because when you were taking the square root, you were looking for the length of the hypotenuse or something, and you can't have a negative length on those, so you only use the positive. But the negative still existed, it just was an extraneous answer. Okay? So don't forget that. You don't want that to be your downfall. And then, yes, I'm not finished. I have to move this 1. So I'm going to have y equals plus or minus square root of x plus 3 minus 1. Can I do 3 minus 1? No, because the 3 is under the square root. The 1 is not. I cannot simplify that anymore. That is my answer. This is explicitly solved for y. So now I need to figure out if it's a function. I don't expect that you know what this looks like. That's fine. You wouldn't be expected to at this point, so we're going to have to look at it a little bit differently. If I have an x value in a function, how many y values can go with that one x value? Just one. I can't have, 9 go with 3 and 9 go with 5. 9 could only go with 3, and if it goes with 5 also, then that's a problem. We're not a function. Function machine, you put it in, it spits out one answer. So we got to figure out when I substitute in an x, how many y's could it possibly spit out? So let's do something simple like 9. Like 6. So I'm going to substitute in 6 right here. 6 plus 3 is 9. Square root of 9 is 3, right? So I'd have a positive 3 minus 1, which is 2. And I'd have a negative 3 minus 1, which is negative 4. So substituting in that 1x gives me 2 y's. Is this a function? No. So I'd say not a function. Make sense? Any questions? All right. So let's look at number 5. I want to get y by itself. So I'm going to move this x. Well, I could move the x, but I'd rather this whole term be positive. So I'm going to move this whole term over here and move the 8 over here all in one step. So this is going to give me x minus 8 equals the square root of y plus 1. So I just kind of skipped a step in there, which is fine. It's fine to skip some steps. You can't skip all steps. And there's some steps you can't skip. So I'm going to make sure I'm clear on all that. Everybody okay with where all that came from? Okay, so now, again, trying to get y by itself. Can I subtract 1 right now? No, I cannot. So I have to take care of the square root. What's the opposite of taking the square root? Squaring. So I'm going to square both sides. So on the left-hand side, that gives me x minus 8 squared. I'm going to leave it like that right now. Maybe I need to square it out. Maybe I don't. We'll see. But I can tell you, you need to know what it's not. It is not x squared minus 64. You do not just square both of them. Big fat no. That gets you in math jail too. All right, so then this equals just y plus 1. then I need to subtract the 1, so I get x minus 8 squared minus 1 equals, no, minus 1, but it's a y. Minus 1 equals y. Can I do negative 8 minus 1? No. So I am done. And there's no reason for me to square that out. So, do you know the basic shape of that if you were to graph it? A parabola, yes. And is a parabola a function? Yes. I mean, this is a parabola that's got some transformations. It's something you got to be able to recognize. So yes, it is a function. It will have y values that repeat, but that's fine. Just can't have x values that repeat. Okay. Everybody good? All right, so let's look at number 6. My goal is to get y by itself. So I have two terms that have y in them. I'm going to leave them on the left. So I get xy minus 5y, and then I'm going to add the 1, equals 2x plus 1. Okay. So now I've got to figure out how to get y all by itself. I have two terms with y. I need just one term with y, and I can't combine those because they're not like terms. But do the two terms have something in common? They both have a y, right? So they have a common factor. What can you do when you have a common factor? Or a greatest common factor? I can factor it out. Exactly. So I can factor out this y. And that leaves me with x minus 5. And that's equal to 2x plus 1. Now, on the left, I have one big term. It's being multiplied. So since to get y by itself, I'm just going to divide. You get y equals 2x plus 1 over x minus 5. That is explicitly solved for y. Can I cancel those x's out? No. Big fat no. Don't try to do that. I don't expect for you to know what this looks like at this point either. Okay? So we just have to think, all right, well, what if I substituted something in? Let's say we substitute in a 3. So substitute in 3, okay, 2 times 3 is 6 plus 1 is 7 over a negative 2. Well, that's just one y value. Can you think of a number that you would substitute in and it would give you two y values? Like, is that possible with this equation? It's not, right? So since I can't get two y values out, is this a function? Yes, it is. It'll give me just one, so this is a function. Any questions at all? All right. So there were little things in there. It's not just about knowing whether or not something is a function, but those little algebraic mistakes that I see a lot. Just pay attention. Make sure that you are not making up math along the way. All right. So let's talk about function notation. So explicit functions are frequently written using function notation. That is, if they are functions. So if I have an equation like y equals 3x squared plus 7, that is a function, so I can say that y is a function of x because y is dependent on whatever's going on with x. So since y is a function of x, can have function of x, which that's really what that means, equals 3x squared plus 7. So if you have f of x, g of x, h of x, whatever of x, that is your function value or your y value. Anytime that you have the value of the function, that's your y value. And this, of course, hopefully you know, it is f of x. If that's brand new information, I'd be a little worried. But any questions? We all good? All right. Move on. Okay, so now we're going to evaluate functions. And there's a lot of times in the notes where I will write more steps than what I might write if I was working it out, or even what I would expect you to, but I don't want to lose you because I know you're looking down and writing and looking back up and where the heck did that come from? It's also not a bad idea to have extra steps, at least in your notes. That way, when you're looking at your own notes, you're not wondering where the heck did that come from. So just saying. But we're going to talk about what steps you absolutely can't skip no matter who's doing it and how. And that is going to be the first step. It's the most important. So q of x equals the square root of 6 minus 2x, and we want q of negative 15. Okay? So first step should always be, if you're evaluating something, zero work. You just substitute it in. I don't care how easy it is, you substitute it in, and that's all you do. So if I want q of negative 15, that's equal to the square root of 6 minus 2 times negative 15. Okay? All I did was substitute it in. When you're in calculus, sometimes you can stop there and you're done and you don't have to do anything else. And either way, that might be a point, or that at least shows your process. So if you do multiply wrong or something, you don't get it totally wrong. Okay? So then we can clean it up a little bit. It's going to give me the square root of 6, and then negative times negative is positive, so it'll be plus 30. So that's the square root of 36. So Q of negative 15 is 6. Should it be plus or minus 6? Did we introduce that square root, or was it already there? It was already there. So if it's already there, you just do what it is. I didn't put it in there. It was already there, so I'm not going to add plus or minus. This is your answer. Okay? Now, you could have skipped one of these steps. Again, I was just kind of writing everything out. So it is okay to kind of skip middle steps, but the beginning step and the end step where you actually label your answer, you can't just have a 6 floating around there. Like, what does 6 even mean? 6 is Q of negative 15. Okay? We good on that? Awesome. All right, so let's look at number 13. On mine, this looks like a blob. I don't know if you could read it, but there's an X up here in the exponent. So this is, I want to have f of 4, and that's equal to 5 times negative 3 to the 4th power. Can I start by doing 5 times negative 3? No, only if I want to get it wrong, right? So that's a no. All right, so then I'm going to have to take negative 3 to the 4th power. Now, we're not going to touch calculators in here until, I don't know if it's December or January, I forget, but it's going to be quite a while. And if you just do everything on a calculator when you leave here, you're not going to be able to think through things on a test or a quiz. So I don't expect you to be, have little calculator brains where you can just spit it out, but I'm going to train some of you. Some of your brains already work this way, but some of you that are like, would always do things the hard way, I'm going to try and train you to think a little bit differently about these numbers. If I want to take 3 to the, first of all, if I do negative 3 to the 4th power, is my answer going to be positive or negative? Positive. So I can forget about the sign then. That way it's not confusing me more. So basically I got to do 3 times 3 times 3 times 3, which is not super hard. And I could do 3 times 3 is 9, times 3 is 27, times 3 is whatever. But I could also do it this way. And when you do it, you wouldn't necessarily have to write it down. I just don't want you to, I want you to see what I'm trying to say here. So this is technically 3 times 3 times 3 times 3, right? So again, I could just start from the left and go to the right. But if you learn how to manipulate numbers in your brain to simplify it for yourself, things become much easier. Because if I do this, this gives me 9 times 9, and that's 81, and I didn't really have to use any brain cells at all. Okay? Does that make sense? So when I show you these things, think about it. I'm not saying this is the only way, and I am definitely not saying my way is the best way, because I understand that our brains work differently, but I'm just going to give you some options about how to think through numbers so it doesn't always seem so difficult to you. Okay? So that means that I have here 5 times 81. Now, you may have to go like, okay, 81 times 5 and go old school, whatever. And there's nothing wrong with that. I mean, we're going to get the same answer. But when I multiply a single digit times a double digit, I usually break this into tens and ones. So I'll do 5 times 80, which is easy. What's that? 5 times 8 is 40, right? So it's 400. And then 5 times 1 is 5. And you wouldn't necessarily have to write anything down. Again, I didn't want to lose you, but sometimes I jot things down or I'll forget what the first number was, but I'm a lot older than you, so maybe you'll remember. But so my answer is just 405. So f of 4 is 405. And we didn't have a calculator, but we all survived, and it wasn't that bad. And I do realize some of you, before I said anything, you already knew that because your brain can just do. That's great. Don't brag because people will not be happy with that. And that's fine. You do whatever makes the most sense to you. I just want to, some of you I know are always going to do things the hard way, and I'm trying to help you with that. Okay? We good? All right. So let's look at 15. 15, what I'm substituting in, has variables in it, so most likely when I'm done, unless everything cancels out, I'll have some variables, which is fine. So I want f of 3y squared. So when I substitute it in, that's going to give me 3y squared to the 3rd power plus x squared. No, it's not. Oh my gosh. Sorry. Plus 3y squared, duh, because we're substituting it in, to the 2nd power. So my power to a power rule, which I get to use because there is no addition and subtraction in here. It's why I get to use this rule. That means I'm just going to take this cubed and it's going to go onto both of them. So this will be 3 cubed, and then y squared cubed. What do I do with the exponents? Multiply them. When it's power to a power, you multiply. So this will be y to the 6th plus 3 squared y to the 4th. So then what is 3 cubed? 9 times 3, which is 27. Y to the 6th plus 9y to the 4th. Can I combine those two terms? No, because my y's don't match, right? So I can't do that. That means I'm done. This is f of 3y squared. This is my answer. So you can't skip this step because this is where you're substituting it in. You can't skip this step because this is your answer. But you could have gone straight to here. Like instead of writing, you don't have to write this. I just want to make sure everybody understood what was going on with the exponents. If you say, okay, I know that's 3 cubed and that's 27, that's perfectly fine. Okay, you're showing where it came from and where you get to. There's not always a ton of steps in between, and that's okay. That's still considered showing your work. Everybody good? Any questions? All right, so let's look at 16. I want g of negative 5c. That's equal to, I'm just substituting it in, 3 times negative 5c minus 10 over negative 5c plus 5. So I'm going to clean up the numerator. It's going to give me negative 15c minus 10 over negative 5c plus 5. Can I cancel these c's out? That's a big fat no. Now, and the reason is because I have addition and subtraction. If all I had was negative 15c over negative 5c, then I could definitely cancel the c's out, and I could reduce this, and it would give me 3 in the end. Okay? But I can't do that because there's addition and subtraction. I can't reduce the negative 15 and the 5, and I can't reduce the c. Now, that does not mean, or I can't cancel it out now, that doesn't mean I can't simplify this fraction. I just can't do what some of you are going to initially want to do and just start knocking things out. Both the numerator and the denominator have GCFs in them, right? So if I got a GCF, I can factor it out. You could use 5 or negative 5. I'm going to use negative 5. So we're going to factor out a negative 5 in the numerator. That's going to leave me with 3c, then what? Plus 2. Good. And then the denominator, I'm also going to factor out a negative 5. And that leaves me with c, what? Minus 1. Okay. Now, can I simplify this fraction? Yes, because I have basically one big term in the numerator, one big term in the denominator, and these are being multiplied. So I can knock those out, and I would get g of negative 5c equals 3c plus 2 over c minus 1. Okay? Now, if I'd have factored out a positive 5 instead of a negative 5, my answer would look a little bit different, but it would have the same value, and both of them would have been fine. So if that ever happens and yours looks different than your neighbor's, it doesn't mean that you're wrong. There's just more than one answer there. Okay? Any questions at all? Okay, so the concept of a function, the concept of substituting in, that should all be a piece of cake. But pay attention to the things that I'm telling you, because I see the same mistakes over and over again. Careful with your reducing that you're not making up math, okay? All right, questions on 17? Or it's not question. Did you have a question? Are you good? Okay, it's okay to ask me a question too. It's okay to ask your neighbor, I don't care. All right, so on 17, we're going to find h of 2a plus 7. So I want you to go ahead and just, the first step is substitute it in. Substitute it in and stop. Let's see, everybody's here but Holly, is that correct? Shout out to Holly, that's probably going to have to watch this video. All right, so when I substitute it in, it's like 2a plus 7 squared minus 2a plus 7 minus 1. Are those parentheses important? Yes, both sets, right? And maybe they would be and maybe they would. Like if this was a plus, then the second set isn't necessarily important, but I still would have done the same thing because I don't want to end up in math jail. Here's another prisoner. They substituted more than one term and did not use parentheses. That can get you in a lot of trouble. So if you're going to substitute anything at any time with more than one term, you put parentheses around it. If they don't matter, great. If they do, you're less likely to make a weird mistake somewhere, okay? All right, so then we need to actually simplify this, which means I have to actually square this. When I square this, it's important that you know what it's not. It is not 4a squared plus 49. You do not get to distribute the square. This is different than this. I got to distribute the square here because notice here, no plus or minus. Here, I have two terms, so it's not a distribution thing, okay? This is a perfect square trinomial. There is a pattern to it, and a shortcut pattern, whatever you want to call it. Or the other way to write that is 2a plus 7 times 2a plus 7. And then you FOIL or box or whatever. So if you don't know the pattern, you got to know how to do it correctly. I don't care. I'm not that picky about how you do it as long as you're doing it legally and correctly. All right? So I will talk you through the pattern because I don't want to go through all the other stuff. And it works like this. You square the first one, so that's 4a squared. Then you multiply the two together, that's 14a, and you double it. So that's plus 28a. And then you square the last one, and that's 49. Okay? You got a perfect square trinomial? So if you were going to square a binomial, you will end up with a trinomial every time. If you didn't, you messed it up somewhere. Okay? So then I'm going to get negative 2a, and then what do I write? Minus 7 minus 1. If you need to do the little arrows so you don't forget to distribute. However, sometimes I see students do the arrows and then they still don't distribute, and that's a brain fart, and I can't help you with those because we all have them. All right, everybody with me so far? Now we just combine like terms, so I only have one squared term, so that is 4a squared. Then I have 28a and negative 2a, so that's plus 26a. 49 minus 7 is 42, minus 1 is a positive 41. And then this is h of 2a plus 7. And we are done. So sometimes when you evaluate, you have variables, and we're going to do different things for different reasons, but this is just practicing some of our basic skills. All right? Everybody good? Any questions at all about where anything came from? Don't be afraid to ask. Promise I'm not going to make you feel stupid. I'm not going to let anybody else make you feel stupid either. All right. So we also need to be able to evaluate using the graph. And don't worry, I know it's tiny. I'm not going to make you count all these little, as long as we understand the concept, I'll give you some of the numbers. So it says using the graph, find each function value. So the function value is the y value, right? And plus it says f of 1, so f of x is y anyway. What does 1 represent? The x value, right? And so then that's going to equal some y value. So I go to 1 on the x-axis, which is right here. That means my y value is right here. Would you agree with that? So again, I know it's tiny. I'm not going to make you count. As long as you understand where it is, that is negative 9. Yes? So we should be able to pull it off a graph like that. But no, only when you're told to. You got to be careful pulling numbers off a graph when you think it's right on something, but it's not, and you can't assume it's half, things like that. So just, there's kind of a fine line there sometimes. All right, f of negative 2. What is f of negative 2? 0. F of 5, 1, 2, 3, 1, 2, 3, 4, 5. Looks like it's right here at 6. And then f of 0 is right here. Given that we know what f of 1 is, what's f of 0? Negative 8, exactly. So hopefully that's a piece of cake. But any questions? If any of the stuff that we just went through, you're like, oh gosh, like the squaring and all that kind of stuff, then go do your summer assignment and get it figured out. Okay? We good? Awesome. All right, so I'm going to hand out, go ahead and get this put on page 22. While you're doing that, I'm going to hand out your worksheet, and then I'm going to go over one of the problems with you. Tell me why on the assignment I feel like I probably need to do number 1. What's already freaking you out? Yeah, the negative 3, the fraction, right? Because I don't know that I've ever really found many students that love fractions, but going to have to get to a point where even if you still hate them, you cannot avoid them. You have to know your basic fraction properties. We're going to do fractions that don't just have numbers in them. A calculator's not going to do you any good to do that. You can't change it to a decimal. Don't ever do that. So you have to not be afraid of them, basically. So I'm going to show you 2 different ways to approach this one. So let's see, we've got x minus 3/2 y equals negative 12. And I know that there's some of you that this wouldn't bother you at all, but I know that there's quite a few where it does. So I'm trying to get y by itself. So the fraction is not going to scare me right now because I just need to move this x. So that's going to give me negative 3/2 y equals negative x minus 12. Okay. Then I have a couple of options on how I want to handle this fraction. The first thing I'm going to show you, because I'm going to work this 2 different ways, is just clearing the fraction, because that can be helpful in other things, just to get rid of the fraction. I mean, I'm not afraid of fractions. I'm pretty confident in my fraction rules, but there are times where I clear the fraction too, just by the nature of the problem. So what I mean by clear the fraction is if I multiply this fraction by 2, it'll no longer be a fraction, right? But if you're going to do that, you have to multiply every single term by 2. And that's where the mistake comes in when people do this sometimes. So then this 2 cancels this one out. So I'm going to get negative 3y equals negative 2x minus 24. So now it's just a basic equation and there's no fractions in there for me to be afraid of anymore. My next step would be to divide each term, each term by a negative 3. And those cancel out. And I get y equals positive 2/3 x plus 8. Okay. Then we're going to look at it a different way, because you really kind of need to know both anyway. If I start at this step where I had this negative 3/2 y equals negative x minus 12. And if you wrote this first one down and you don't have to have room, just at least follow along with what I'm doing. So since I have something being multiplied by y, what I really want to do is divide by whatever that is. So if I divide by negative 3/2, that's the same as multiplying by the reciprocal, right? So I can multiply by a negative 2/3, and I can multiply this side by a negative 2/3. So these cancel out to be 1, so I get y equals, then when I distribute this gives me positive 2/3 x, and then 24 divided by 3, positive 8. You're actually doing the same thing, but it's just the process looks a little bit different. And again, I'm not that picky on how you do it. As long as you're doing it efficiently, correctly, and legally, we're good. Okay? Any questions? All right, so on this, I'm going to be looking at your work. So I can read bad handwriting for the most part. If I can't read it, it must be really, really bad. But there's a difference between bad handwriting and unorganized work, because some people can have very good handwriting, but their work doesn't make any sense. Your work has to have a flow that anybody that has any clue about math could follow along with what you're doing. Okay, so you can't just have stuff everywhere. And it doesn't necessarily have to look exactly like mine, but, just organized in some fashion. All right, we good? Any questions? All right, so got about 5 minutes left, so you get to work on this, not putting it up. And what I would suggest is tuck, if you're going to do that, tuck this in there. Otherwise, if this gets humid, it's going to stick to your papers. Does that make sense? The flap on that envelope, tuck it in the envelope, because if you leave it out and the sticky part's showing, and it's so humid around here, if it gets any wet, it's going to stick to your papers and you'll get frustrated. So just tuck it in the envelope. All right, but you got 5 minutes to work. So work, work, work.